Jumpstart Pro Android utilizes the web authentication mechanisms in order for it to provide authentication. However, how does that work with API communication, and how does the application know that it's logged in? Let's go ahead and hop into that. First thing, we're going to visit the login screen, which if we click the menu and click login, we'll be presented with a web-based login. Here you can log in with a username and password. So if we type in a password here, a username and a password such as I have here, we'll be logged in to our instance. Now at this point, we're logged in, we can view what's new, the notifications, etc., everything inside of here. But how does this work behind the scenes? Let's hop into the code and take a look. Behind the scenes, Jumpstart Pro Android is using an Android WebView for its communication to the web. Now, inside of the WebView, we have a cookie manager that's used by default. And as we can see here, it manages the cookies used by an application's WebView instances. So as soon as the Rails app sends back some cookies, such as the authentication cookies and all that kind of stuff, and the session cookies, they will be stored inside of the cookie manager. So inside of our application, we can then determine based upon the cookie manager for that given URL if we are logged in or not. Back inside of the application, we can look at the user repository and we see we have a method called isLoggedIn. If we look at the implementation of that, all it does is check to see if the cookie manager has a cookie. So if we look at the cookie manager delegate, which is just a delegate to the cookie manager itself, we can see, do we have a cookie for a given URL? This URL is provided to us from dependency injection. This base URL is provided over in the base URL module. If we take a look at here, we can see that it is using the default config value, which is in debug set to 10.0.2.2. This is build config file is generated at compile time. And again, this is located inside of the build.gradle.kts file. Well, the definition of it for it is at compile time, this build config field will be generated if release build with this value, in debug with this value, and in staging with this value. So as we can see here, we are running in a debug build, so we get the base URL here. And then back in the cookie manager delegate, when this is created from dependency injection, we will pass that base URL in here and we can check the cookie manager to get a cookie based on that URL. Do we have a cookie for this URL? If so, then we are logged in because that is the value that's been sent back from the server. If not, then we are not considered to be logged in. Okay, that makes sense. Now, how does this work in relation to the Android application and the server? Now, if we go take a look at Jumpstart Pro, Jumpstart Pro will automatically log you in with a traditional login mechanism. However, what happens after post login is what's important. Inside of the authentication file, we see the after sign-in path for a particular resource or scope. What happens here is if we detect that we are in a Hotwire native application, this method simply just checks the user agent to determine if we are using a Hotwire native app. If the user agent is that, Hotwire Turbo, Hotwire Native, etc., we're going to return them to reset app. Now, reset app is a path that is defined in our Rails application. And the Rails application, it doesn't do anything. So if we take a look at here, it just says redirecting on the view. So what does this mean and why do we have this? If we look at the path configurations file inside of Jumpstart Pro, we will see that we have a path configuration for reset app. Now this is the path configuration that Jumpstart Pro Android reads when it starts up. We can see that on the web here. And here down at the bottom, we'll see that we have a reset app pattern and rule. What this means is that the application can handle the reset app. So as soon as that's hit, the application can run some native code, such as a fragment, and then perform some type of operation from there. So in the application, let's go take a look at Jumpstart Android, and we'll see that we actually have a reset app fragment, and we match that URI here. So the reset app fragment will get invoked as soon as the reset app route has hit. So after the Rails app logs in, we detect if we are in a Hotwire context. If we are, a Hotwire native context, we will redirect to reset app. Immediately, the native app will then hop in and the reset app fragment will be called. Here, we do a couple of things. We check to see if the user's logged in. If so, we update some local state informing the app, hey, we're logged in. And anyone who's listening to this login state can then react to those types of scenarios. Now inside the main activity, we actually have some code where we react to this login state, and that's going to be in the main activity view model. you can see right here, we're going to perform some type of action based upon the login state. In this situation, we're going to detect if we're logged in and we require authentication, do we show or hide tabs, etc. So we're going to go back to the reset app fragment. At this point in time, we're just going to grab the home URL, and then we're going to reset the navigation graph and just say, hey, send us back to the home URL, and we'll go back to what's now is the dashboard here. So the user is logged in and we're looking back again at a web page. So what ends up happening is we're on a WebView, which is the sign in WebView, which is in a Rails app. We log into the information, we log into the site sends up the data that it needs. The Rails app replies back saying, we are now redirecting you to reset app. In that request, it's also including some cookies. And because Android's WebView uses the CookieManager, those cookies are stored inside of that CookieManager. We then are automatically forwarded to reset app. The native app hops in and says, hey, I can handle reset app. It shows this reset app fragment. We could check to see if we're logged in, and the login, all it does is check to make sure that we do have a cookie for that given local URL that we are connecting against. If we do, we consider this to be a logged in state. And then at that point in time, the user repository notifies everyone that we are now logged in. So this works great because now we have the cookies, and all web views will be sent back and forth with the WebView and the CookieManager, and that's all handled for us out of the box. We don't have to do anything else extra. However, the challenge now becomes, what do we do when we need to communicate with the backend server? Maybe we need to register a notification token. Maybe we need to sign out, so we need to deregister the notification token. Or maybe we have a custom API and we want to send that up from a local HTTP client that's on the native Android app. How do we handle those types of scenarios, and where would we find one? One of the first places we find one is when we're registering for a notification token. And that's going to be the notification token component. This is a Hotwire bridge component. This is connected as soon as the website provides a bridge, a controller saying, hey, we want to connect to a given resource on the native app. In this case, it's going to be for the notification token. In the Rails application in this instance, what we do is if the user signed in, we'll then show this bridge component. And all this really does is add this data controller in here, bridge notification token. At that point in time, the stimulus controller will be invoked, which is the bridge component. And in turn, this bridge component will be called in the native app. This is how Hotwire Native connects everything together. Once this is called, we are now in a native context again. So the site has said, hey, you're now logged in, register for a notification token via a bridge component. The bridge component gets invoked on the Android client. And then we need to say, hey, register for notifications. And if we look at the implementation of this, we're going to skip the couple of things down here. Once we get a notification token from Firebase, which is our notification service, we need to persist that notification token. And looking at the implementation of this, you can see that we communicate with our API service, and our API service adds a notification token. The API service simply talks to the notification endpoint, which is going to be in the API endpoints, notifications, and it's going to send up some data with it. But for this to work, we need to be able to authenticate so we know which user to add the authentication token to. And to do that, we need to send up the cookie with that request. So how do we do that? Underneath the hood, we use what's known as Retrofit. Retrofit is an HTTP client for Android. That is what you see here on the screen. This is Retrofit. Now, Retrofit is powered by something known as OkHttp. It's the lower level HTTP communication layer that powers the HTTP communication back and forth between the server. Now, we need to be able to tell Retrofit and OkHttp, hey, we have some cookies. You need to add the cookies to your requests, so that when you send the request up, they are seen as authenticated with this given cookie. Now, what we have over in the dependency injection area is we have an HTTP module, and this HTTP module builds our Retrofit instance. And when we build Retrofit, we have to provide the base URL, we have to provide some JSON adapter converters so we can handle JSON and so forth like that. And then we also need to provide it with an OkHttp client, which is optional. It has a default implementation, but we can provide our own. And then we can say, hey, here's how I want you to handle some HTTP communication. And that is provided to us up here. Now, this is actually provided in a method right above it. It's called provide OkHttp client. And what this does is allow us to set some logging on it, which is what we do here. But the important part here is we can add some interceptors to OkHttp. And these interceptors will allow us to intercept requests and responses from the API to do stuff with them. And we have one very interesting interceptor called the Cookie Interceptor. Now the Cookie Interceptor does something very interesting. It takes in the app URLs and gets the CookieManager that we're currently working with. And then what that does is it checks the original request. It sees if we have a cookie that's inside of the CookieManager for that URL that we have passed in for the app URLs. And then we build a request based on top of this. If the cookie string is not empty, so if we have a cookie, we want to add that cookie to the request. So here, the code will add a cookie to the request. If we're logged in, we're gonna have a cookie. So we're gonna take that cookie from the CookieManager and we're gonna shove it into this HTTP request. From there, we'll rebuild the request and then we'll say chain.proceed, which means to continue on the chain of execution. Now, also, sometimes the server can send back an updated cookie, such as set cookie. So we check the response header to see, for whatever reason, if the API has returned back a set cookie response. If so, then we're gonna go ahead and set that updated cookie with that same URL back into the CookieManager. So we make sure we have the correct cookie going forward, regardless if things have been updated or not. If there has been no set cookie, then we completely avoid that. Now at this point in time, anytime we use retrofit, which is we have an API service, which is powered by retrofit. These are all powered by retrofit. Any of these calls here will automatically have their cookie added to them, and any updates to the cookie will automatically be persisted to the CookieManager. And that's how we can log in from an API perspective with a local HTTP client, as well as allowing the WebViews to just manage the cookies themselves, because that's what the CookieManager does inside of the Android WebKit WebView. Okay, so we have logged in. We know that we can communicate in a web context very easily because the WebView manages the cookies and that's handled for us. We have seen how we can communicate with an API because we just add the cookie to the request for us from the CookieManager. So all of that's really handled really nicely. But what do we do when we log out? Now, when we log out, we're actually using a Hotwire bridge component to tell the app that you need to log out. And that's going to be in the sign out component. The sign out component gets called from the server when the user taps the sign out button in the menu on the web menu that invokes a bridge component to say, hey, we are going to sign out, which is the message being sent right here. As soon as we receive this message on the Hotwire native bridge component, we say, hey, it's sign out. We're going to call a sign out method. At that point in time, we're going to go ahead and launch a asynchronous call from the Kotlin coroutines, and that's right here. We're going to launch a background task to do something in the background. And so we're going to sign the user out, and the user repository sign out. If we take a look at the implementation here, all it does is it calls the API service. This is the same thing we saw before. So it's going to add that cookie there, call the API service, say, hey, we want to log out. And what this is going to do is it's going to unregister the notification token on the server, basically telling Jumpstart Rails, hey, this application, this client is now logging out. Delete the notification token for it because it's no longer valid. The user is signing out. At that point in time, we'll then go ahead and clear the user data. What we do at that point is we just grab the CookieManager delegate, which again is just a call into the regular CookieManager. And then we say, want to clear all the cookies and remove all the cookies and flush them from the system. We'll take any of the shared preferences, which is where we should store some temporary data for state. We'll clear that out. And then we're going to set the login state to logged out. And again, anyone who's listening to this will now be logged out. And again, that happens in the main activity view models where a lot of those subscriptions happen. Now, once that is complete, what we will do, the result has, we've been signed out. We're going to handle the sign out state. At this point in time, we'll see if the request was a success or if it was a failure. If it was a success, let's go ahead and get the app reset URL, which again, we've already spoke about the reset URL. And then we're going to go ahead and route to the app reset URL. If there's an error, we're not going to do anything. We're just going to go ahead and log it and show a dialogue, a native dialogue to the user with the error message that something happened. So once the user signed out, it's a success. We're going to route back to reset app fragment. Now we're going to come in here. We're going to realize that we're not logged in anymore. So it's going to skip this completely right here. This gives the application or you, this is the developer, a chance to do some other type of setup or resetting of the app or anything like that. Now at this point in time, we'll take the home URL and we will reset and redirect back to the home URL. So we treat the reset app route as a way for us to kind of reset the application either into the logged in state or a logged out state. And that's how authentication works in Jumpstart Pro Android.